Okay, good afternoon. So in theory, you've completed these surveys that I sent out yesterday. So if you can just pass those to the front of the room, then I'll come around and collect them in a moment. Yep. So there's two. Let me see what there's actually two versions of the survey. Oh, I see. This is like, you mean, is it sort of per month or per year or something like that? I think it is for the next 12 months. I think it's yearly because it's said for the next 12 months the drop will be X. Oh, I interpreted the per year The last one, which version of the survey did you have here?
Oh, we had the phone?
There's two versions. This is like on a per capita basis. Yeah, this would just be like total.
Yeah. Per year.
Yeah, because you basically be selling the rights off once, and then it's okay. It's not like you're not going to be graded on this. That's why we have many data points. Are there any other surveys? Okay, that's fine. Okay, well, I'll tabulate these, or Gavin will tabulate these in a few days or something, and then I'll discuss the results later. If there are any other surveys, you can just also hand them to me at the end of class. Okay, so what you just did, like what that survey represents, is basically an application of what we call the stated preferences methodology, also known as contingent valuation. And basically what this methodology involves is just asking people how much they'd be willing to pay for a good. So it's sort of conceptually similar to revealed preferences in the sense that we're trying to elicit or measure how much people are willing to pay or willing to accept. But the difference is that instead of actually observing a market transaction, you're just going to straight out approach people and say, look, how much are you willing to pay for this particular public good or for this environmental amenity? And the advantage of this is that you, the street researcher, can construct any hypothetical scenario that you'd like. So the problem with the revealed preferences methodology is that it can be difficult to find instances in which the public good or the environmental good that you're interested in is actually bundled into a market transaction. So we discussed the example last time where we were talking about like the value of good public schools, and so we looked at housing market transactions because the public school system or the assignment to a specific public school system is basically bundled into the particular house, and so you can do comparisons between two houses that have pretty similar attributes and are very close to each other, but actually are assigned to different public school systems. So in that case, it's feasible to use the revealed preferences methodology, but in a lot of other cases, it can be really difficult or outright impossible. So if you were going to sort of try to generally measure how much people would be willing to pay to avoid global warming, you couldn't really come up with like a market transaction where global warming is like, or the effects of global warming are basically bundled into some particular good. Maybe if there were like property on Mars and it weren't experiencing global warming and it were costless to travel there and all their attributes were similar to Earth except for that, then you could look at the price differentials between those two planets. But needless to say, that is extremely not at all representative of reality. So in those sort of situations where you can't find a market transaction that's bundling in the environmental good or the public good that you're interested in measuring, you have to sort of resort to just asking people outright, well, how much would you be willing to pay for this particular good? So just to give some examples, you could think about asking people how much you would be willing to accept in order to allow drilling in the Arctic National Wildlife Refuge, how much would you be willing to pay to prevent a 5-degree increase in global temperatures, or how much would you be willing to pay to avoid a 1 in 10,000 chance of a serious injury. So the survey that you had you fill out in between class basically was a contingent valuation example, and I'll tabulate those results and we'll discuss them in a couple lectures. But the problem with contingent valuation is that the respondent may not essentially put his money where his or her mouth is. So the real question that you have is, you can ask people, well, how much would you be willing to pay for this particular environmental good? But you don't know, just because they answer $50 or $100 or $200, you don't know that if they were actually faced with that real life choice and they had to spend real money on it, that they would make the same decision as they're reporting. And there's several reasons why we think that the response that people give may diverge from what they would actually do if they were using real money. And the biases are essentially the following three, or the primary biases that we worry about are the following three. So one is what we call strategic bias. And the idea here is that you may misreport how much you're willing to pay in order to advance your own agenda. So, for example, let's suppose that you go and knock on the door of the president of the Sierra Club or something like that, right? So that's somebody who presumably has very strong environmental preferences and probably would be willing to pay a significant amount in order to, say, not have oil drilling in the Arctic National Wildlife Refuge or something like that, right? So they'd probably give you a pretty high number, which wouldn't surprise you. But the problem is they may get an even higher number than they would actually be willing to pay, right? Because the thing is they know that they're not going to be required to actually pay this amount, right? So if their goal is to prevent the drilling, then they could say, well, actually I'd be willing to pay $100,000 to prevent the drilling. And maybe they would be willing to pay a fair amount, but they probably wouldn't actually be willing to pay $100,000. But since they know that you're not going to actually force them to pay that amount, they might as well just inflate it and sort of increase the measured willingness to pay in the survey, which could then potentially affect public policy if you then use the results from the survey to make an argument as to whether or not we should be drilling in the wildlife refuge or not. So you could have a strategic bias there. The second problem that you run into is what we call framing bias. So in the first case, people in the first case, the respondent is basically maximizing their own utility and figuring out that sort of inflating their own answer is to their own benefit, given that they won't be held accountable in terms of having to pay what they're requiring. In the second case, it's more of sort of an error on the part of the researcher, in that the wording of the question itself might affect the answer that you get. So, for example, you might not want to go and sort of ask somebody just in a free-form question, how much would you be willing to pay? You might want to sort of give them a bunch of different possible choices that they could choose from, and then have them choose one of those particular choices. So that's what happened in the survey, right? Like I didn't ask you just fill in a number that represents your willingness to pay. Instead, I had a bunch of different numbers in there that you could choose between. And so you can imagine that if you can almost think of like the different numbers as like running a little sort of mini auction, right? Where you're sort of giving the respondent a choice to go for $0 or $20 or $40 or $60 and so forth. And you can imagine that where you start that auction at could potentially affect people's answers. So certainly, if you start at $0 versus if you start at $50, like if somebody wanted to choose say $40 and you started at 50 in one case and you started at 0 in another case, then that's going to have a clear impact on their answer, because in the $50 case they can't actually choose $40, so they may just say like, well, I'll choose 50 because that's kind of close, even though it's not exactly what I'd like to respond. So in that case, you kind of get like a direct bias that's clearly going to manifest itself. But even if the answer were something above $50, like even if their willingness to pay were definitely above $50, starting at $50 versus starting at $0 might still end up having an effect on what they're willing to pay, right? Because it sort of frames what the baseline is. So maybe they want to pay a fair amount, but they're not quite sure what that is. And so if you start at $50, maybe they say, well, I'm not going to pay I'm not willing to pay just the minimum. I'd be willing to pay 100 or something like that. Whereas if you start at $0, maybe they'd say again, well, I value this good. I don't want to just pay the minimum, but I don't know exactly what a fair amount is. Maybe it's like around $50 or something. So where you actually set the starting point could kind of frame how they're going to value the good and then affect their answers, which is not what you really want, right? Like you want to be eliciting some sort of quote unquote true value, and that true value ideally would not depend on exactly how the question is worded. And I think this is, I guess even if you were playing with real money, it could still be a problem, right? Like if you think about stores that sort of double the price and then say, well, everything's 50% off, that's kind of, they haven't changed the actual price that you would be paying relative to if you just had, like, this is the price and you won't get any money off, or you won't get any discount on it. But, people sort of think like, oh, well, I would have normally had to pay $100 for this shirt or something, and now it's half off, it's only $50, ignoring the fact that maybe another store is actually selling the same shirt for $50 but with no discount. So certainly in sort of the retail sector, there's a lot of research and at least I think there's this belief that how you sort of frame the pricing can certainly affect what people are ultimately willing to pay. So that's the second kind of bias. And then the third main type of bias is what we call information bias. So this is sort of a two-part problem. So the first part is the respondent may not comprehend the questions, and maybe that's because the question didn't have enough information, as was the case in some of these survey questions where you weren't quite sure if it was per month or per year or what. But it's also possible that some of these questions basically involve like figuring out probabilities and doing various calculations, right? So in the case of the survey that I gave you guys, you would theoretically kind of have to do some calculations about the riskiness of having vehicles with airbags and without airbags and so forth. In some cases, that information wasn't even given to you, but in other cases, like depending on which survey you got, I actually gave you the information on what the exact probabilities are, or at least what you should think the exact probabilities are. But even in the case where you're given that information, you still have to kind of go through your head and think about like, well, here's the chances that this airbag would end up saving my life, and here's like the risk that I'm willing to take, and so forth. And if you were playing with real money, like if you're actually deciding whether or not to pay an extra several $100s or whatever to get the safety feature, then you might find it worth your while to like sit down and figure out how much risk it's actually saving you and whether or not you think that's worth it. But if you're just filling out a survey and you're not going to have to pay, and I'm not going to grade you on it and so forth, then you don't really have that much incentive to like sit down and do the calculations and figure out what your true willingness to pay is. So the sort of information bias takes two parts. One is that you may not know exactly what your answer is until you like do some additional calculations, and then the second part is conditional on that. Given that you don't actually have any money at stake, you may not be willing to take the time to do those calculations because it's just annoying. Karen? Right. So that's a good question, and that can also be a problem. So so when people are deciding whether or not to buy safety features in their cars, they have presumably some perception in their head of like. I guess I was thinking more about that. Okay. That, like, it's so like away from me that you don't really know how to value it. Right. So I think that's definitely a problem. So you're saying like, are you sort of? You guys are very familiar with the limit. Right. So like, if you were saying, well, there's some wildlife refuge in some place in the world that you've never heard of, how much would you be willing to pay to preserve it or something, right? So I guess I guess the one answer could be that, well, if you don't know about it and you don't really care about it, then probably your willingness to pay is very low, and that's in some sense like. The environmentalists probably wouldn't agree with that, but the economists might say, well, we basically elicited what your willingness to pay is, and it's not very much. So in some cases, I think that even if you were using the reveal preferences methodology where you were somehow getting people to actually spend real money on this, they still might not be willing to pay very much. That being said, I think it could also be the case that you could end up in this last situation if you were using the stated preference methodology, which is that they don't really know about it, but maybe if like there was something, they felt like there was some real issue or some real potential environmental destruction at stake, they might take the time to like sit down and read about it or something and figure out like, is this something worth protecting? Whereas when you ask the survey, maybe they're just like, whatever, this is just some hypothetical situation, I don't really care. They might answer 0, or maybe they might be like, well, I don't know, it sounds good to me, I know I don't have to pay for it, so I'll just do some high value or something. So I think again, the problem or was stated, you could have biases or sort of a lack of information in either case, but it's always going to be the case that with stated preferences methodology, people aren't going to have any incentive to sort of take the time to do the research or anything. Whereas at least when you're dealing with real money, they might have some incentive to do so. I think so. A related point is also that so if you take like the case from the survey where I asked you about like how much would you be willing to pay for airbags. So this was like stated preferences survey, so you can answer whatever you want, and there's no ramifications for doing so. That type of situation though does lend itself to like a reveal preferences approach because there are actually safety features, like additional safety features that are available on cars, and you can pay extra to get them, and so people are in those cases actually paying real money for it. But even in those cases, I think there is some question about what people's perception is in terms of the probabilities at stake. So presumably if they're willing to pay more for the safety feature, they believe that it will actually protect them, but we don't know how much they think it's going to protect them. We don't know if they think it's going to decrease their probability of dying by 1 in 10,000 or 1 in 100,000 or 1 in 500 or what. And we might be able to measure those true probabilities, but even if we measure the actual safety benefit of that feature, that doesn't mean that people themselves who are making those decisions have that number in their head because they might be mistaken for whatever reason. Okay, so because of these three types of biases, we're going to actually sort of focus primarily on reveal preferences studies in this course to the degree that we look at willingness to pay for environmental goods. So I think that these contingent valuation state preference studies have their place, and sometimes it's all that's available. But I think ideally we try to avoid doing them when possible. Like if we can do a reveal preferences approach, then we choose to do that usually. And I think there's sort of not so much sort of thinking about like actual academic research. There's probably more that's done with reveal preferences approach and not so much done with stated preferences. In part because like doing a stated preferences study doesn't require you to have all that much training. Given what I've told you guys, like even without a PhD, you could probably do a state preferences study. You just need to figure out what good it is that you want to measure the value of, and then fill out, make up some survey that elicits how much people are willing to pay for that. That's a little bit of an oversimplification because there are people who kind of look into sort of the optimal way to design the study to avoid like the framing biases and so forth. But I think you can only go so far to try to eliminate these biases, and at the end of the day, something's going to remain in terms of potentially biasing your results. Okay, so then the last thing that I want to talk about in this lecture is benefit cost analyses. So this is a important thing from a policy perspective, because at the end of the day, usually we need to figure out whether or not we want to go ahead with some particular policy. And if you want to make an informed decision about whether or not you're going to go ahead with a policy, then you need to have some sort of metric for deciding, at what point is this policy going to be worthwhile and at what point is it not going to be worthwhile. So benefit cost analyses are typically a way that you might determine whether or not to go ahead with a policy, and they basically just involve determining whether the net benefits of a policy are positive or negative. So you might think that one way to decide whether or not to implement a policy would be to determine whether or not that policy were Pareto improving, right? So if you remember back to the beginning of the class, we talked about Pareto efficiency, we talked about Pareto improvement. So a Pareto improving trade, or a Pareto improving policy in this case, would be one that makes some people better off and makes nobody worse off. And so that is sort of a very appealing kind of criterion, because it's hard for anybody to argue against a policy that's making some people better off and not making anybody worse off. So it's appealing, but in general, it's kind of impractical to try to design policies in ways that are Pareto improving. And the reason is that it's usually difficult to design a policy in which nobody loses. So just to give one example, we talk about how pricing parking at well below the market price or giving away for free can result in a market failure. And so you could improve efficiency by pricing it at the market price. But even in those cases where you're moving from an equilibrium that is less efficient to an equilibrium that is more efficient, it's not going to be the case that everybody is going to be better off. And so in particular, if you think about market priced parking, when you move to a case or from a world in which you have free parking to one in which you have market price parking, usually the people who are going to lose in that transition are the people with a low value of time. So you might be able to empathize with that depending on how much spare time you have. But the problem there is that basically what's happening is so when you go from, say, free parking to market price parking, right, you're reassigning spaces in general from people who aren't willing to pay very much for them to people who are willing to pay more for them. So the people who didn't have a space before but were willing to pay a lot for them will end up being better off, because they're going to get the space, and in general, space is probably going to be even more valuable to them than the price they have to pay. So they'll, from their perspective, this new policy will be better. But there will also be some people who essentially were willing to drive around in circles for a long time looking for parking, and that was because their value of time was relatively low. And of course, they would have preferred to just go straight to the space and have it be free and not have to waste any time finding it. But given the choice between either circling the block for 10 minutes to find parking and then having it be free versus being able to go straight to the space and then paying, whatever, say like $8 for it or something, they might well choose rationally the former situation where they were circling the block, basically using up their own time and then getting the space. So if that's the case, then implementing a market here is going to make them worse off. So on net, the people who benefit from this will end up, their gain will be greater than the loss for the people who are being made worse off by this policy. But despite that fact, there are going to be some people who are made worse off. So another example would be that's not even environmental or public goods related, really, would be something like free trade, right? So presumably in Econ 1, one of the first things that you learn is free trade is good. Why would you not have free trade? You have basically the mutual benefits of free trade if both parties were not being made better off. So you think about say China and the US trading. China is going to sell us something. We're going to buy it. Obviously, we must think that we're better off buying it. Otherwise, we wouldn't have bought it. Obviously, they must think that they're better off selling it. Otherwise, they wouldn't have sold it. And so this should be a win-win situation. But of course, then there are these other effects in terms of manufacturing job loss in the United States, which in theory, if markets work perfectly, wouldn't really be an issue because these workers would immediately find new jobs. But in practice, that's not really how markets work. There are frictions, right? And so the case of free trade is a case where, on net, the benefits of going from a protectionist system without free trade to a system with free trade are probably unambiguously positive. But that's not the same thing as saying that free trade, moving from a policy of no free trade to one with free trade, is Pareto improving. Because there will be some people who end up losing their jobs. Those people will be unambiguously worse off. And unless you compensate them in some way, you can't say that everybody's being made better off with nobody else being made worse off. So in practice, implementing markets is not Pareto improving. Now, the thing that's nice about sort of going to a case with free trade or going to a case where you have market price parking instead of free parking is that the gains for the winners are large enough that in theory you could compensate the losers, right? So in the case of the market price parking, basically what you have is you have a situation where you move to this new equilibrium where there are people who are paying a significant amount of money to park in the space. There are some people who formerly got spaces because they were willing to queue up and circle around when they were free, who are no longer getting spaces. Those people are worse off. But now you have this huge pot of new revenue that's being collected from the actual parking fee, right? And so in theory, you could take that revenue and use some of that revenue to compensate the loser. So it could be some sort of tax cut or whatever, or some sort of service day value, something in theory. So in principle, you can in fact sort of through redistribution turn this into a Pareto improving move. But the problem is that in practice, how you identify the losers is going to be difficult. So, once you say, look, there's this big pot of money, and if you were made worse off by this policy, then we're going to compensate you. Then of course everybody's going to claim to be made worse off by this policy because everybody's going to want compensation. And maybe in some cases it may be pretty easy to determine who the winners are and who the losers are, and so perhaps in those cases you could come up with some sort of compensation. But in a lot of cases it's going to be somewhat ambiguous, and everybody's going to have an incentive to claim that they are made worse off and deserve some sort of compensation. So in practice, it can be very difficult to find policies that are Pareto improving. So given that constraint, what we often do is instead strive to maximize net benefits. So the name for doing this is basically called the Calder-Hicks criteria. And the idea is that you want to maximize the net benefit of an activity. So mathematically, what you would the problem that you're solving is that you want to maximize with respect to Q, the difference between B of Q and C of Q. In this case, B are the benefits of the activity, C are the costs, and Q is the quantity of the activity. So if you solve that problem, then what you'll see is that the first order condition, so if you differentiate that function with respect to Q, the first order condition is going to be that B prime of Q minus C prime of Q is equal to 0, which is the same as saying that B prime of Q should be equal to C prime of Q at the optimum. And that's just saying, look, we want to set the marginal benefits equal to the marginal cost. So again, as I said previously, the answer to most questions is that you set two marginal quantities equal to each other. And the idea here is we just want to figure out what the total benefits are, figure out what the total costs are, and set the marginal benefits equal to the marginal costs. And this is sort of equivalent to thinking about, or to